This next set of videos is going to teach you how to solve non-right angle triangles. So when you have a right angle triangle, you can use Pythagorean theorem or you can use the three trig ratios. When you have a non-right angle triangle, you can use what we call the sine law, or what we're going to learn next is what's called the cosine law. So the sine law is used only when you have a known angle across from a known side. So to use the sine law, you have to have one known ratio. You either have to know angle A and the side across from it, or angle B and the side across from it, or angle C and the side across from it. You only have to have one known ratio. So the way that we set up the sine law is that if you want to find a side, I always put my unknown on my top. So if I want to find a side, I'm going to put the unknown side on the top, and across from it, I'll have the ratio of the sine of the angle. Now, if I was solving for angle A, side A, I'd have to know side B across from angle B, or I'd have to know side C across from angle C. So you're only going to use two of these. So you'll say maybe A is to angle A as B is to angle B, or A is to angle A as C is to angle C. So you're only using one proportion, so one part of this equation. So let's look to see what that means. So here is a non-right angle triangle. You can tell because there's no square in a corner. And this says solve for side side C and B to the nearest 10th. So looking at this question, I have a known angle across from a known side. What that means is that I can solve for either an angle or a side, depending upon what else is known. So here I also know another angle, so I can solve for the side across from it. So if this is angle C, I'm going to call this little c. So to set up my proportion, I never use for these ones I don't write literal equations, I just think of what it's doing. So it's setting up proportionality. It's saying side C is to angle C. Now angle C won't have any value unless you put the sign with it. So it's saying side C is to the ratio of opposite to hypotenuse for the angle 72 as side B, A, which is 6, is to the angle across from it, so the sine of the angle 56. So using this proportional statement, I can now solve for side C. And by setting this up with my unknown on the top, it's really easy to solve. All I have to do is multiply both sides by the sine of 72. So I'm going to plug into my calculator 6 times the sine of 72 divided by the sine of 56. Now, depending on how your calculator works, you might want to type 6 times the sine of 72 equals, and then hit divided by the sine of 56. It should know where to put the brackets, but if it doesn't, just be careful. So to the nearest 10th, you should find that side C is 6.9. So now I want you to use the same triangle, but this time I want you to solve for side B. So B is to angle B, but we don't know angle B. But we do know a rule. Angles in a triangle add up to 180 degrees. So A plus B plus C is going to equal 180 degrees. So if I'm trying to solve for angle B, I'm going to take 180 degrees and subtract the other two angles. So minus 72 and minus 56. So angle B is 52 degrees. So side B is crossed from the sine of 52 degrees, just like. Now, you have two known proportions. You have side C that you know across from angle C, and you have side A across from angle A. You can use either proportion, but because we just solved for C, I'd have to use an unrounded version, which means I'm keeping a lot of numbers. And what if I made a mistake? So I always use known values if possible. So I'm going to say side B is to angle B, as side A, which is 6, is to angle A, which is 56. So then to plug this into my calculator, again, to solve for B, I just times both sides by the sine of 52. And I get B equals 6 times the sine of 52 equals divided by the sine of 56. And I get to the nearest 10th 5.7. 7. So this is how to use the sine law to solve for a missing side.